Let us today study about metals and heat treatments of the metals. So let's dive into the topic and know heat treatments of metals. There are different types which we can see in this picture, and we'll see them one by one. The purpose of heat treatment is to increase ductility, strength, toughness, increase machinability, relieve internal stresses, to improve corrosion resistance and hardness. Ductility is nothing but which we can use it in wire. Machinability is such as we want some parts to be machined on the wing structure or on the surface where they want the thin metal, but they want it to give it some shape. Now process of heat treatment is heating, then keep it in that temperature, and then letting it soak in that temperature either through air or either in some medium like oil or water, and then cooling it for a while, so that if we want a part to be soft, it will be softened. If we want the part to be hard, we will again do the process so that we get the desired material or desired metal. Now types of heat treatments are annealing, normalizing, hardening, tempering, case hardening. Case hardening is further done in 4 ways: case carburizing, cyaniding, nitriding, and flame hardening. Let's dive into the topic further. Temperature range for heat treatments are: normalizing is done above 1000 degrees Celsius and above the critical temperature, which is shown in this picture. 0.8% carbon is always there in the metal. Then in this part we can see that annealing is done at 723 degrees Celsius to above just below the critical range. Then hardening is done at that temperature where annealing is done, and normalizing is above 1000. Now annealing, heating above critical temperature, soaking it for 1 or 2 hours, slow cooling to release internal stresses and rearrange ferrite or pearlite structure. In simple terms, annealing is softening the material so that we can use it in wire or wherever the ductile part is required. Here annealing always releases internal stresses and it makes the material soft enough to be used in a small area or where wires can be formed. The purpose of annealing is to relieve internal stresses, refine grain so that it can be electrically useful, increase ductility to be used in wire, increase toughness, increase machinability, where we can use it in the form of sheets or plates. Now normalizing. Normalizing is done above the critical temperature, heating material above 40 to 50 degrees Celsius above critical temperature, holding it for about 15 minutes, and then cooling it slowly in normal air or ambient temperature so the desired metal can be. Normalizing reduces the hardness so that it can be formed into a ductile metal and refines internal stresses. Now we can see annealed metals and hardened metals. Normalizing is used to eliminate internal stresses, increase strength. Normalizing is done on cold work parts to remove stresses and restructure the material grain so that we can use it in a ductile format or where we require a ductile part. Now hardening. Hardening is heating the material above critical temperature, holding it to that temperature, and quenching. Quenching is dipping the material directly into water or oil or polymer bath. Purpose is to increase hardness, improve strength or toughness or elasticity. Hardening is basically to harden the material by phase shifting internally, and wherever we require tough hard metal, we do the hardening process by heating it above critical temperature. Now we'll see what is tempering. Now that we know hardening, we should know what is tempering. Tempering is done after hardening to release internal stresses produced due to rapid cooling by quenching. Then reheating the material, holding at that temperature and then slowly cooling it. Once we do hardening, then we cool it rapidly, then we again reheat at temperature and then slowly we cool it. This will give us this will reduce internal stresses and restore the ductility properties, toughness and shock resistance property of the tempered material. Tempering. Now we'll see case hardening. Case hardening is done to give surface hardening. Case carburizing, cyaniding, nitriding and flame hardening. Case carburizing is heating with charcoal or carbon around the surface. Then carbon forms metal solution in iron. Then high carbon content increased with hardness. Then hard case outside and tough core inside. These are the ways case carburizing is done to obtain such metals. Now cyaniding is done, where material is immersed in bath of sodium chloride and sodium carbonate and sodium cyanide at 800 to 900 degrees Celsius and dipped in cold bath for quenching. Uniform hardness is obtained by cyaniding and then great surface finish. Wherever we want smooth surface finish, we do cyaniding. Now we'll see nitriding. Steel is heated above 500 degrees Celsius in presence of ammonia and then nitrides are formed on the surface. Nitrides are hard in nature. Now we'll see last but not the least, flame hardening. The surface which is to be hardened is heated by oxyacetylene flame and then quenching is done, where we dip it in a solution. Specific part of the surface can easily be hardened by this method because hardening is done by heating and quenching it in solution. Now summary, heat treatments are done to improve mechanical properties. Case hardening is required to reduce surface wear of parts without losing core toughness. It is used in gears, engine parts, aeroplanes, diesel engine parts, pump shafts, gauges, dies, etc. Now that we know, we work in aviation industry, we know that most of the parts that we require has gone through heat treatment process, and different types of heat treatment process that they have gone through we can understand from this